So welcome everybody. Here it says Computer Science 3200, but of course, as you all know, this is what we call a piggybacked course, so there are grad students and undergrad students in the same classroom. So wherever you see Computer Science or Comp 3200, just replace that with 6980 if you're in the 6980 course. So there are two different Brightspace D2L shells for this course. One is for 3200 and one is for 6980. Just for simplicity, I'm only going to load up the 3200 one because I believe there's like 75 people in the class for 3200 and 25 for 6980. So that's the way it goes. You'll see grad students and undergrad students in the same classroom. And this is one of my favorite courses to teach. I've designed this course as a course that I would like to take, and so hopefully you enjoy it as well. I've gotten good feedback in the past, and if you ever have any feedback for me as the course goes along, please feel free to send me an email or stop by an office hour or message me on Discord or anything like that. I'm always open to making the courses better because hopefully that makes you learn better, which is the entire goal. So the first class, what I'm going to do is I'm just going to go through everything that I've written down. And so I'm just going to read through it, and that may sound boring. I know you're all capable of reading, or at least I hope you are. But I'm going to read through this so that if I spot any mistakes, I can change them to what the correct thing is supposed to be. So we'll go through what's written in the Brightspace announcement. If I say Brightspace or D2L, they're interchangeable terms. I'll go through the announcement here, and then I will go through the slides, which covers the course syllabus, the marking scheme, stuff like that. And then there's maybe 20 minutes to 30 minutes at the end of like what is artificial intelligence and what to expect out of the course. Just a little tip for next time. I never expect to see half of you again. I am perfectly well aware of what releasing lecture videos does. I get this like exponential drop off in students until there's like the 20 hardcores who keep coming to class. So I fully expect to not see a lot of you, but I do recommend coming to class because historically I have found that the people who do by far the best in the course are the people who come to class and can interact and ask questions, etc. Also, I am well aware of how terrible those chairs are. I have sat in them as a student. I do not enjoy them. But we are stuck with this classroom. It is the only one that was left that had lecture capture, so I apologize. And for the final exam, at least, I'm going to try and get us in a different room so you don't have to write the exams on those stupid things. But we're probably stuck here for the midterm. So again, apologies for that. If I could get you the big lecture theater with nice seats and everything, I would, but I'm stuck with what the administration gives me. And also, because of the layout of this room, as you can notice right now, there's like a lot of people sat at the edges and almost nobody in the middle. When you come in, try and sit at the middle, and that way if anyone comes late, they're not like climbing over you to get to a seat. It just makes it a lot less distracting when people come in a few minutes late and they're climbing over people. All right, that's the last I'll say about that. Let's grab into the course, or get into the course. So again, hello everyone. Welcome to Comp 3200. Let me make this a bit bigger. There we go. Thank you for registering for the course. Our course this term will be in-person lecturing with in-person exams. If it were up to me, well, it is up to me, sort of, I would love this course to be entirely programming. The only method of evaluation would be programming, but unfortunately, you have a few cheaters among you. There's always some who either get carried through the assignments by their partners or fall to the temptations of AI code generation or whatever. And so the only way for me to truly evaluate your skills, because the goal here is to learn, believe it or not to just hand me a piece of code that works. Anyone can hand me a piece of code that works because there are tools out there for that now. But the goal is to learn, and the only way that I can truly evaluate your knowledge is in-person written exams. Well, when it comes to an algorithms course. Yes, the assignments are still a big part of it. I wish it could all be assignments and project work, but unfortunately, the world just doesn't work like that anymore. So this class will be taught simultaneously with the graduate version of the course. This means that both grads and undergrads will be present in the same room for the course lectures. The main difference between the two versions will be the increased difficulty of assignments and exams for the graduate version. So you're all listening to the same lectures, but the graduate students are going to have to do some extra stuff on the assignments, and they'll have a little bit harder exams. Here is all the info you need to know about the course. So you have showed up, so you know where and when the class is. The first class is today, so congratulations for getting that right. Here is a link to a Google spreadsheet. So if I come over here, this is both for your benefit and for my benefit, mostly for my benefit because I'm by nature a very disorganized person, so I have to be extra organized when it comes to the class. Here are all the lectures for the class. Unless something dramatic happens, this will be the way that it's going to be. These 2 lectures right here are new for this offering of the course. I have condensed a few lectures, like for example, game theory used to be 2 lectures, but the second lecture was only like a half an hour for some reason. So I condensed those, and I have room to fit some new stuff in there. So other than these 2, which are subject to change and subject to me making them good enough to be deliverable for this term, here's how the course will be. The midterm exam will pretty much just cover everything up to what we covered in the midterm, and then the final will be mostly stuff from the second half, but about a third is the stuff from the first half as well. In this spreadsheet as I go, what I will do is post links to the slides and to the video, which will be posted on YouTube. I used to post things to the videos to D2L as well, but because now we have 2 courses and 2 different shells, that's going to be super annoying. And oh, actually, it's going to be annoying because that gets posted to the shell and it's only one of the courses. So maybe I'll have to come up with something else. That link will work. Maybe there'll be 2 PDFs, one for the grads, one for the undergrads. I'll have to figure that out as I go. But you'll be able to access the slides and the videos, no problem. It also tells you if it's blue, that's when an assignment is given out. And in this class, unfortunately, a little bit for you, there is always an assignment due. And so what I have is that whenever an assignment is given out, that's when the previous one is due. And so the reason I've done this is to just give you as much time as possible to work on something. So for example here, assignment 2, you have like 3 weeks to work on assignment 2 because it's due when I give out assignment 3. What I could have done is just say, okay, you have 2 weeks to work on it, and it's not due on the same day, but I just give you as much time as possible. So all that is there. Over here is like when all the assignments are due. You can click on a link to the MUN calendar. So anyway, this will be like your portal to the course if you want to just open up this and see what's happening. Also, I'm going to mention that this is my teaching website. So if you want to go directly to the course on Brightspace, these are links to the courses, links to the spreadsheet. It's the same spreadsheet for both courses. It's the same. This will go to a YouTube playlist of all the lectures, but it hasn't started yet, so there's no link there right now. And if you click on this, it'll take you to the course syllabus. So all the information is there. And I should note that I do keep all my lectures up from previous offerings of the courses. But, and so if you're super keen and you want to watch ahead, you can, but keep in mind that some things do change from year to year. I'd say 5 to 10% of the course material will be tweaked or updated or whatever. So you can watch things ahead, but please watch this year's videos because anything I said in a previous year's video could have changed. Okay, so they are available to you, but I don't necessarily recommend relying on those videos. Yeah, so that's the teaching website. Let's go back to here. So this course will make use of D2L, Brightspace, my website, which I just showed, and a Discord. So I do have a Discord server. Who here has used Discord before? Okay, about 3/4 of the class. So that is completely optional, but I do find it's the easiest way to communicate. Some people will ask a question in the public channel. I can reply publicly so everyone gets that information. Sometimes someone will post, oh, where's the link to this? And then another student will reply with the answer, which cuts down on my work. So it's a nice little community there that you can join the Discord. I'll make a post this evening with a link to the Discord, but I just wanted to chat about that first. All the course content will be conveniently linked on a Google spreadsheet. Okay, I already talked about that. Here is my teaching website. Already talked about that. All important course announcements will be made via D2L. Please make sure to enable email notifications so you don't miss any. So sometimes I'll do an @everyone on Discord to say something, but I will do that in addition to making that on D2L. So for the people who don't join the Discord server, I can't be making announcements there that I don't make on Brightspace. So D2L, that's where all the important announcements will be made. Assignments. I'll get into this a lot more when the assignments start, but I'm a bit unique when it comes to giving out assignments. So all students in the class will be emailed a link to your @mun.ca email address where you can download a personalized copy of each assignment once it has been released. I'll talk about this a lot more when I get into it. But instead of me just saying, here's a zip file, everyone download it, the zip files are actually going to be unique to you with your information in them. This is an anti-cheating measure that I put in years ago and has worked very, very well. All assignments will be submitted via D2L as a single zip file for each assignment. Actually, this is not going to be a single zip file, that's going to be a single JavaScript file. So you'll just write the assignment in one file and then you'll upload that. That's how we'll mark it, so I'll have to change that. Due to the rise in cheating and assignment sharing, your personal information, name, and student number will be embedded into each file of the assignment in plain text, metadata, as well as hidden text. This is to prevent the release of assignments and their solutions online outside of the class setting. What does that mean? Well, there's a lot of course like assignment selling websites and stuff, you know, these like shady Russian sites where you can go on and buy assignments. This means that if you do upload your assignment, I'll be able to trace it back to you. So don't do that. It will not work out well for you. I'm completely chill, like as a person and as a professor, unless you upload your stuff online or you cheat. Those are the two lines that I don't have any tolerance for. So as long as that, I will sit down with you for an hour and try and solve the mistake that you made in your assignment, but there will be absolutely no mercy for people who do stuff like this because you ruin it for everybody. And of course, you can roll your eyes and say, I would never do that, but there's always, unfortunately, a few people who do like doing stuff like that. Anyone's assignment found publicly online for any reason will suffer strict academic penalties. So if you use GitHub to collaborate with your assignment partner, just make it private. Make it a private repo, that's all. It's not difficult. And you know, if I find I do a few searches for certain keywords throughout the year. If I find, you know, you forgot to make assignment 1 public, you're not going to fail the course or be booted out or anything like that. I'm just going to remind you, please make that private, etc. All assignments will be done using very basic vanilla JavaScript and HTML. The reason for JavaScript is because it's super easy. You don't need a fancy IDE. I can make really nice graphical user interfaces in HTML, and it works out really well for this course. And since this is an algorithms course at heart, it is not specific to any individual programming language. So anything you write in JavaScript here, you could easily write in C, C++, you know, Go, Rust, Python, whatever you want. But this is an algorithms course, so it's good that you understand the algorithms. And for the small subset of JavaScript that we will be using for this course, it'll actually be quite a nice language to use because it's just very simple. That doesn't mean that I'm a big fan of the JavaScript language. There are things you can do in JavaScript that are absolutely terrible, but hopefully we will be avoiding those things in this course. As you may have imagined already, no use of ChatGPT, Copilot, or any other code generation software is allowed in this course for the completion of assignments. I will be treating AI-generated code that is submitted as cheating and will pursue very harsh academic penalties for its use. So like the baseline, what happens, is at least a 0 in the assignment. That's like the starting point. Okay, I'm not afraid to hand out zeros if people cheat. So please don't fall victim to the temptation of the dark side of ChatGPT. Class Discord server, I have a Discord server for my classes. I said all this already. Just please set your server nickname to your actual name, because as much as I enjoy getting 3 a.m. Private messages from XX420 Blaze It, I would like to know who you are, right? It literally happens. There are some wildly inappropriate usernames out there. Please spare us from them. Yes, you had a question.
I have a question about the assignments.
Yep.
So I read in the course outline you can work in groups of 2. So how will that work?
I'll get into all of that. Okay. Yeah, I have slides on that, but thank you. Lecture delivery information, I mentioned all of this. Oh yeah, just because lectures will be recorded, you're still encouraged to attend class. This lecture recording system is not perfect. Sometimes they are missed. And if you miss it, I'm sorry, you just missed it. I'm not going to individually give you the lecture again in my office hour. So please come to class if you can. But if it does work, it will be posted. And I do a lot of work to try and get those lecture videos in a good state. I put like timestamps in the YouTube videos and stuff to different chapters and different topics. So, yeah. This class will have an in-person midterm and final exam, and I will provide lots of details about those as we get closer to those dates. Okay, so now I'm not going to go over the exact syllabus because I have copied and pasted elements of this into my lecture slides, and so I'll go over it in that way. So let's start with the lecture slides. So first, I'm going to go over a little bit more course information, maybe some duplicate information, but maybe some more detail, and then I'll talk about a little bit about AI, the whole thing that this course is about. So this course is about what I would call classical AI algorithms, right? So we're talking about single agent search, adversarial search, optimizations and data structures, problem solving, new lecture in this term, constraint satisfaction problems, evolutionary algorithms, reinforcement learning, and a very brief introduction to neural networks. So if you thought this is going to be the course where you learn all about machine learning, or how LLMs work, or how to implement stuff like that, that is not this course. There's an entire machine learning course for that. This is sort of the, oh wow, there's a whole lot more to AI than ChatGPT, right? There was a lot more AI going on as far back as the 50s, 60s, 70s, 80s. Like, you know, there's lots of AI that is not machine learning or neural networks, believe it or not. But I do touch on reinforcement learning, which is a subtopic of machine learning. And I do, you know, the course really wouldn't be complete without at least explaining how a neural net works. So that will be toward the end of the course. But basically, the first half of the course is all about search and optimization and planning. And then the second half of the course is evolutionary algorithms, reinforcement learning, stuff like that. So what is the goal of this course? This is actually a more interesting topic than you might think, what the goal is. So the goal is to learn about artificial intelligence. The goal is not to produce the fastest code. The goal is not to hand in an assignment that works. The goal is to learn how to do those things, right? So I'll have a few more comments about this later, but like, I want to know that you are capable of doing these things on your own and implementing these things from scratch, right? Writing your own arrays to put the data structures in. Like writing the loops, you know, writing the variables. I want to know that you understand these algorithms. So I am going to take great efforts to make you understand them. I don't want you to just be able to give me a solution. I want you to understand the whole pathway to that solution, because that is what learning really is. So I want you to learn how to identify problems, how to choose representations for those problems, and we'll talk about different representations of actions and environments and spaces and all that kind of stuff, and how to find solutions to those problems. And a big part of that is understanding which algorithms to use in which specific problem space or in instances or scenarios of those problems, and the benefits and drawbacks to each of those. Not just, okay, throw it at ChatGPT. Okay, throw it at a deep neural network. Believe it or not, that's not always the best thing, right? There are solutions that can run on like Raspberry Pi nanos that are better than you'll get from a deep neural network, right? It's a whole world of artificial intelligence out there that has nothing to do with that topic. So the course structure, Tuesday and Thursday when the lectures are, there is no mandatory text, but there are 2 textbooks listed on the course syllabus. I didn't paste them into here, which is unfortunate. Those are both excellent textbooks, and if you follow along with the topics in the table of content from those textbooks, I'm sure it will be beneficial, but they are not required to complete the course. I'm not making you go out and buy those textbooks. I'm not a fan of you having to spend money on things. Online sessions and help, I'm always available via email. I prefer that you use my Gmail address that's listed on my website, because I've had my MUN account like run out of space, or like the server goes down for a bit and I miss something. So I would prefer using Gmail. My office hours are currently Thursday from 3:30 to 5, so that's right after class on Thursday. and I'm pretty much always available on Discord. Now, I say always available. I'm constantly in online mode. Like, I just have a Discord monitor at home, so if I don't get back to you right away, I will get back to you within a day, usually. Textbook is not required, and as such, the slides are designed to be study material. So when you're giving like effective presentations, I am a strong believer in the less text, the better, right? But for this course, I am designing the slides to be your study material. And so that's why I do have more text on some of these slides than I would normally have if I was giving a presentation at a conference or something like that. So that's why a lot of the times I will be reading. I'll have supplemental text like I'm doing right now, but the important notes are always going to be on the slides. So you should be able to do all of the assignments, exams, from the slides. So I've had some people hand in an assignment that was just obviously from somewhere else, because I teach the course in a specific way that I think is the best way, or one of the better ways, to understand the flow. Like in my opinion, every good course tells a story, right? And so following along that story, you're going to learn things in a very specific way, and then I get an assignment that is just very obviously copy and pasted from Wikipedia. And that hurts me, not because it's copy and pasting, but because if you're going to cheat from my slides. They're better, right? So don't go to all these external sources. Like, I mean, you can. They'll have a different viewpoint, and maybe it'll help you understand. But a lot of the stuff will be in the slides, so stick to the slides whenever possible. And the class lectures are going to be a mix of the slides as other demos and visuals, etc. So I try and be as visual as possible, because a lot of these problems are pretty visual in nature. And the slides will be given as PDF files because the PowerPoint files are quite large. And so just keep in mind, when I give you the slides, it won't have any of the videos or the animations. It'll just be a still image. So you can go back to the lecture video if you want to watch any of the animations or anything like that I did. There will be a total of 5 total assignments worth 40% of the course mark, and so 60% will be exams. You can work in groups of up to 2 people. I highly recommend working in groups of 2 people because the assignments have been designed to be done by 2 people. Many people have taken the course and done it solo, but if you are not particularly strong in this particular field, you may find it challenging to do the assignment solo. Also, I truly believe that pair programming can produce something that is better than either of you could have produced individually. From talking back and forth to each other, helping each other solve problems, etc. I think that working in groups is what you're going to be doing for the rest of your lives as programmers. So I like people working in groups. Each assignment will essentially be to apply what we just learned to a simple game-like environment. And also, something to keep note is that I am very open to listening to any problems that you are having. I know people have like lives. Some of you have jobs. Maybe most of you have jobs. And so if something comes up where you need a little bit of extra time on an assignment, come to me before the due date. If you come to me on the due date, I'm not listening to it. Okay? Unless there was like a car accident or something like that. But you're going to have between 2 and 3 weeks to do each assignment. So if you wait until 6 hours before the due date to come to me with the excuse, there's nothing we can do. Come to me when the problem happens. Hey, my partner dropped the course. That's a pretty valid excuse, right? But tell me when they dropped the course, not 2 weeks later, right? You don't want to be that person at the restaurant who eats 3/4 of the burger and then tries to send it back because it was no good, right? Like, you can't have your cake and eat it too. So please come to me when the problems happen. Oh, and also, not explicitly listed here, but I will post it on D2L, that I have a one-time get-out-of-jail-free 48-hour extension for any assignment in the class. So all you have to do to use that is that if you submit an assignment and it's late, the TA will ask you, hey, are you using your free 48-hour extension on this? And if you say yes, there will be no mark deduction, and they'll mark it down. I highly recommend not using that on assignment 1. Assignment 1 is going to be the easiest assignment. Don't use that on assignment 1. Other than that 48-hour extension that you get for free, no questions asked, Any assignment that you submit, every hour that it's late is 5% off. It's a very simple thing. If it's 3 hours late, it's 15% off. Okay, so there's no arguing, oh, I was late this time, please don't take off marks, etc. No, you had 3 weeks. If it's so it's rounded up. So if it's 1 minute late to 1 hour late, 5% off. Okay, it's pretty easy to understand, and it makes it easy for everybody, and we don't have to spend time arguing about it. The midterm and final are worth a total of 60% of the course. Yeah, so group work, generative AI, it's hard to trust assignments only. I have had people, and props to them for being brave enough to tell me, like one group said, yeah, I did the odd assignments and they did the even assignments. Right? Like, please don't do that. Like, everybody should work on all the assignments. I understand that sometimes one person will do more work on one assignment than another assignment, etc., but try and split the grades evenly. So the exams are going to be comprehensive but fair. Like, it's the stuff that's if it appears in a slide or in an assignment, it can be on the exam. And if not, it won't. So if you watched everything and you understood it, you should be fine. I've never gotten any complaints that the exams are too hard. So maybe that means I should make them harder, but I won't. So here's the assignments. We'll have a few search-based assignments and then a GA assignment, reinforcement learning assignment. Here it says that the midterm and the final are 25% and 35%. I think it's actually 24% and 36%. Because the way D2L does it is that the exams are worth 60%, and then the midterm is worth 40% of the 60%. And so whatever that works out to be. So whatever's on D2L, that's the actual locked-in-stone grading scheme. JavaScript programming. Who here has done some JavaScript programming before? Okay, so about half the class. Don't worry. It's dead simple. It could not be easier. If I had given you this in any other language, including Python, it would be harder. Trust me. So many students have completed the course with 0 JavaScript knowledge beforehand. And essentially the way that the assignments are going to work is you'll get a bunch of files, and I have constructed a nice GUI, and you have to write the back-end algorithm. So the GUI will call a function in your algorithm, and you just have to write that function. Couldn't be simpler. But this structure makes it a little bit harder to cheat. Like, yes, there are certain parts, individual functions, etc., that ChatGPT can probably solve. It probably can't solve the whole thing without mistakes. But I strongly recommend against trying to do that. Because as soon as you've put it into ChatGPT, it's tainted your knowledge of that problem, and it will influence how you then write it. And trust me, I have seen every permutation of all the LLMs, all the code that's online. It's almost easier to just do the assignment yourself than it is to not get caught cheating. The TA is really good. He's done it before. And I just tell him, listen, anything that's like too good or has the telltale signs of like all the comments and stuff that ChatGPT does, just let me know. And so then I'll have a look at it. We'll be using very, very basic JavaScript. Loops, functions, classes, objects, arrays. That's basically it. Like just the fundamental building blocks of any programming language. And the syntax for JavaScript is very close to any other programming that you've used. So because of this, we will not need to use any specific IDE. You can literally do this course in Notepad if you want to. I highly recommend against it. I would say the easiest thing to do is just to use VS Code. It's a nice text editor that has JavaScript syntax highlighting, can open up the whole folder. We'll get into that in assignment 1, but that's what I would recommend, but you don't have to use that at all. You can just use whatever you're familiar with. I'm going to go over this again because I want you to know that this is important. All work is going to be group work, except the exams. Keep discussion of the assignments and the project entirely within your own group, if possible. What's going on here? My slides stopped advancing. Oh, that's because I have somehow clicked into the notes section. This slide. One second. Okay, there we go. That's the first time that's ever happened. All right, so we'll be checking very closely for cheating, publishing it very strictly. So we have a tool that just we have collected all the assignments in the past that we have. So you have a buddy who did the course, and you got their assignments. Well, their assignments are in the pool, and we just run this tool that MIT developed that like does differencing with all the So please, it's just way easier to not cheat in the class. And I sound like a broken record, I know, but it's for you. I want you to really learn this, and the reason why is coming up in a bit. And as I alluded to before, there are valid excuses to be late, to not come to class, to miss some work, to not have gotten that lecture on time, etc. But there is no excuse to cheat, right? The cheating, you can't accidentally do that. That is a deliberate thing, and, well, okay. So academic misconduct, I take it very seriously, blah, blah, blah. So here is what I consider cheating. Handing in any material for evaluation that was done not by you or by the group. There will be some very specific examples in the course where I say, hey, this bonus thing, you can use outside sources for that. But unless I explicitly say that, then these rules hold. Obtaining solutions from any non-class source, such as anyone outside your group, previous course offerings, Stack Overflow, etc. Now, again, if you're Googling, how do I sort a JavaScript array, that's fine. Like syntax stuff, API stuff, but not the algorithms, please. Sharing assignment or exam questions outside the course for any reason, including assignment sharing websites or online repos such as GitHub. These files that I give you, this is not an open source course. Okay? If I made this course open source, there would be solutions everywhere and the course would be ruined. So I am desperately trying to stop that from happening. Please have some sympathy. Do not post it online. Or if you reverse engineer any of the obfuscated solution code that may be given to you. So sometimes I'll give you some obfuscated JavaScript code as a solution so you can look at what the solution should look like. And if that happens, again, it will be way easier for you to just do the assignment than to reverse engineer that obfuscated code. So don't do that, et cetera, et cetera. Another anti-cheating measure, all assignment files will be personalized and sent directly to your email. So every file that you receive will have your name, student number, email, all that kind of stuff in it. Don't be worried though, like I'm not putting this online, like it's sent directly to you, right? So don't share that with anyone except your group member. And there's other steganographic information inserted, like the information is encrypted and put in different parts of the files and stuff. So it's difficult to get around that. I'll get to your question in a second. Any files leaked to other groups or online will be traceable back to the original person who had it. Large repositories of past assignments to do code difference checking with. I already said that. You had a question?
So do we just have to copy paste our code to the file you're sending us, or how does it work?
No, you literally open it up and there's a skeleton. Oh. So every assignment, I will have made a skeleton class for you with 5 or 6 functions. You write the functions. That's it. It couldn't be simpler. We'll get into that with assignment 1. I periodically search for code online and stuff. Sometimes someone, 3 years later, they'll post their code for their resume or something like that. Please just post screenshots or videos. Don't post the code online. It's really easy. I just send a DMCA request to GitHub. They take it down because my name is all over the copyright. So ensure the repos are private. And I have to say this because like 3 years ago, someone took code from this course and submitted it in another course as a project. And because I didn't explicitly say that was not cool, the university kind of let them do it. So I'm saying it now. You may not release any source code written for this course at any time, now or in the future, including other courses. So I just have to cover my butt and say that. Now, I said all that. Why shouldn't you be cheating? This is a really interesting topic that I could talk for a long time about. I'm going to talk for a couple of, and this, trust me again, for your benefit. 2 or 3 years ago, I literally had companies calling me asking for recommendations for students. Like, we're hiring 6 people. Dave, do you have any good students? Okay, let me go see who might be looking for work, etc. In 2024, my best students are struggling to get internships, co-ops, interviews. I have some graphs in a second. The job market, the bubble, has popped. It's not terrible. You shouldn't run and go like drop out of computer science. Computer science is still one of the best fields, if not the best field, to get a job in. But the tech market in St. John's and everywhere else in Canada has gone down significantly in the past 1 to 2 years. And for the undergrads in this course, it's double crappy because when you started computer science, that was the top of the bubble, right? So you were probably hearing from your friends, oh, this is the way I get a free job, is to do computer science. And by the time you're graduating, it's not free anymore. Luck has so much to do with your life. You had nothing to do with that decision. You followed the trends, you did your best, and now it's a little bit harder to get a job in the field. So use this course and your other courses to practice the skills that you will need to get the job. What a concept, right? Using the things that you learn to practice the thing you will be doing probably for the rest of your life. A piece of paper saying you graduated is no longer sufficient because there was a time when it was. You walk outside and hold it up, and just like a taxi downtown, there's a job waiting for you. It's unfortunately not like that anymore. And here's the thing. This is the criticism that I get. You will, trust me, you will be using these Gen AI tools to help you in your daily work as a software engineer, developer, programmer. I do. So I can't imagine that you wouldn't. It'll just make you better overall if you have something to help you. And so AI tools can help you be more efficient. For remembering syntax, API calls. I can't remember how many times I've had to Google or look up how to do a specific thing in a specific language because I forgot, right? It can write small pieces of code for you. Hey, ChatGPT, I need to read in CSV where the second and third columns are between 0 and 1 and normalize that for me and like put that into this data structure. If you can have something do that for you, why wouldn't you, right? You just get it done faster. And the whole point of your job at a company is to do things correctly faster because then you'll get more money, right? If you do things faster, it costs the company less. You can use it to paste in some code and say, hey, explain this to me, right? The person who worked here before me, I hope you can read their code because I certainly can, right? There are lots of benefits to LLMs, generative AI, and more recent code like ChatGPT, etc. However, here's the important part. If you don't know what the code it generated does, then you cannot integrate it properly. And it will fail, and it will fail spectacularly. So what I recommend in how to use these tools is use them to either learn or to recall something that you did know that you may have forgotten, but not to implement or integrate. Okay? Because if you don't know what the code you're pasting in does, you're signing a blank check over to the AI system to do whatever it wants. And if then your code breaks and your boss comes to you and says, fix it, you don't know how to fix it. It's a real problem. It's an excellent tool for making you more efficient at something you already know, but it is very dangerous for doing things that you don't already know how to do. So this course is you learning how to do it, and then when you get your job, ChatGPT it up, right? They probably have the pro giga subscription to ChatGPT where it'll produce infinite files for you. I don't care. When you get out of this course, do all that stuff. But please, the goal here is to learn. And hopefully, you won't have access to that on the exams. All right, here's some charts. 2020, 2021, the bubble started. Look at it go, look at it go, look at it go. Oh dear, here's where we are now. So it's not this dire situation where there are no jobs. It's just that it's back to normal. There was this pandemic, work from home, AI bubble that happened, and now the bubble has popped a little bit. I'm actually surprised that it hasn't gone down way more. So I think you're actually like in a lucky situation because in a few years, I think there'll be far fewer jobs than there are now. Here's layoffs. Layoffs are up until, this is accurate as of January 6th, so this is pretty recent. It's kind of stabilized, but there are still these pockets of big layoffs, right? You're not safe just because you're at a big company. Actually kind of is worse if you're at a big company these days. Global venture capital dollars are down, right? Not only that, ghost jobs are a thing. Who's heard of these? Right? Like, it's insane. So there are like weird government programs, and this isn't the only reason for this, but there are all sorts of benefits for companies that governments provide. And one of them, okay, I'm getting a little conspiratorial here, but one of them is like, hey, if you've been looking for people and you can't find anybody, we'll help you pay the salary of someone new or something like that, right? There are programs that exist like that. So what do companies do? They go post a whole bunch of fake jobs that they never planned on hiring for in the first place to convince the government that, hey, we looked and we couldn't find anything. So for all sorts of reasons, there are fake jobs out there, and combine that with the fact that since 2014, computer science enrollment at MUN has almost quadrupled. Those numbers are down a little bit because they've gone down a little bit here to about like right here. Computer science in 2014 was the lowest enrolled science faculty, science department in the science faculty, and now it's the highest other than math and chem, the two subjects that like everyone has to take in their first year, right? So effectively, computer science is like one of the highest enrolled things, and not only that, and for the grad students, you're not really safe either, because a grad degree is the new undergrad degree, right? There's this treadmill of bullshit where like the more people who get degrees, the less those degrees mean, so now you got to go get another degree and another degree, and oh my god. Anyway, I was in university for 15 years. I know all about it. I was very lucky to get this job. Not to say I wouldn't have gotten any job, but like they just happened to be hiring at the time I was graduating. And that's the whim of the universe that you are subject to. I could go on about how much luck has a factor in your careers for a long time, but I got to get through some more slides. Here's a local example. This is not a typical example, but there was a local tech company who posted a junior software AI developer position, and in 2 days they got 300 applications. So look around. There aren't 300 people in this room. Could you beat everyone in this room for that job? As much as we hate to hear it, life is inherently a competition. I wish it wasn't, but the company is out there to make money, right? And they're going to hire the person who can make them the most money. And when you get that tech interview, maybe you have an impressive resume, maybe you bullshitted an impressive resume. I can tell you right now, as someone who has done a lot of interviewing, both for students, for supervision, and for companies, within 90 seconds, I can tell if you're bullshitting me or not, right? Just the way that you talk about things. And my wife also works in tech. She does a bunch of hiring. She does remote interviews. And you can see people with like, oh, what's that little earbud in your ear? Why are you always looking over to the left in the interview? People are trying to fake interviews all over the place. It's crazy out there. So please, it's just, I know that a broken record, etc., but I cannot stress to you how important it is for you to use this opportunity to double dip. Not only can you get your degree, but you can also get really good at the thing you want to do. And if you look at it that way, I think it's a little bit more motivating, other than, I got an assignment due on Thursday. Yeah, I get it. That sucks. This is not your only course. There's going to be a bunch of other courses and a bunch of other Thursdays where assignments are due. But, man, it's kind of brutal out there right now. So, okay, if you can't post your code anywhere, how am I going to build my portfolio or my resume? You can still show off your work. I recommend taking screenshots, videos, do a little YouTube video where your face is up in the corner and you walk through the thing that you did. Have a little website with screenshots and stuff. It's not only the code. You could have all your code in a private repo that you could like show them upon request. But please just don't share the code online. So this code is designed to build your skills and portfolio. Okay, any questions about any of this so far? Pretty self-explanatory, just trying my best to motivate you a little bit. All right. Most importantly, if any of you come to office hours and you want to share pet pictures, these are my cats. And this is our ferret. We used to have a lot of ferrets, but they don't live very long. So I'm always down for sharing some pet photos. If you come in, I'm not going to say there's going to be bonus marks, but there won't not be bonus marks for sharing pet photos. Okay. So what is artificial intelligence? Holy crap, we finally get to the start of the course, right? Dave, shut up and teach us the skills that we need. So AI, what is AI? What a loaded question that is. If you go by what companies say, literally everything is AI. There's AI in my toaster, in my blender, right? In my car, in my whatever. AI everywhere. Okay, what do I think is AI? I will not ask you a question on an exam, what is AI? Okay, and you'll see why. Let's break it down, though. Let's try and understand it. By the way, for anyone who's interested, there is an entire course in the philosophy department about the ethics of AI, where they go into a lot more detail about this. So I'd recommend that if you can sit on that as well. So intelligence. A typical definition of intelligence is something like you have some capacity to learn or reason or understand or solve problems. You know, some sort of effort and decision-making goes into that process, right? Is a plant intelligent? I don't know. I can't photosynthesize. Maybe it is intelligent. Am I intelligent? I hope so. Is a robot intelligent? All of these are questions that go around. So artificial intelligence, I guess in its most basic form, and if you ask 100 AI researchers what AI is, you might get 100 different answers. But I think it is like building a program or a machine that appears intelligent to the user in some domain, right? So it's not necessarily an if-then statement, but if you go into things like game AI, well, the Goombas running around in Mario, that's actually game AI. You have to control those somehow. But it might be just if the player's to the left, move to the left. So like the definitions of AI, they vary between disciplines. They vary whether or not you're talking to someone who's an academic or someone, a citizen out there, if you want to call them that, or you're talking to your mom about AI. Like so many people think AI is just killer robots and Skynet from Terminator. Like there's so many different things that people talk about. There's also this concept of a strong or general AI that's a system that's good at everything. And modern LLMs are definitely making progress toward this, but in my opinion, still don't reach this level. Artificial intelligence was coined by John McCarthy, he developed Lisp, he won the Turing Award, and this is what he had to say. It is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. I think that's the important line here, is that a lot of people think that AI has to do with, okay, it's only neural nets because that might be how our brain works. That's typically not the academic view of it. It's just like, if you build a machine or write a program that does something that someone calls intelligent, it's AI. I think AI is kind of a poor term. I think machine intelligence might be a better term. Because if something is intelligent, what the hell does artificial mean? It is or it isn't, right? It doesn't matter where it came from. I guess you could call it biological intelligence versus machine intelligence, something like that. But you can see it all gets a little bit fuzzy. Another quote I like, AI is the science of making computers do things that require intelligence when done by humans, something like that. There are a lot of different subcategories of AI. Typically, when you talk about research in a particular area, there are two main ways to break down that field. One is in the domain space, that is sort of what it is applied to, right? And the other is in the solution space, like the type of algorithm that's being done. And so this is kind of the domain space of artificial intelligence, where you have things like, well, it's kind of both actually. It says machine learning would be an algorithmic technique that can be used. Natural language processing, that is a domain, right? So there are lots of different ways to break down AI. I guess I would say I'm the most expert at, if I would be called an expert, would be planning, scheduling, optimization, and search, which is what the first half of this course is on. So I'm not going to go over all the different subtopics of AI, because you can basically apply it to everything. Modern artificial intelligence publications I kind of take issue with, because machine learning and LLMs are kind of this Swiss Army knife or big hammer, and what people do who claim to be doing AI research is they take that hammer and they're like, look, I found a nail. Bang, 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 bang. Okay, are you an AI researcher or did you just download TensorFlow? Right? So, you know, am I doing operating systems research because I use Windows? That's kind of how it is, right? So, yeah, just be careful of anyone who says they're doing AI research. Hands up if you know who this person is. Oh, that's depressingly low. Okay. It's Alan Turing, like the grandfather of modern computing. If you have not watched the movie The Imitation Game, I recommend it. It's pretty good. It's not, you know, The Godfather or anything, but it's pretty good. Goes into Alan Turing and his work on cracking the Enigma machine that basically, like, this person, other than maybe the President of the United States, had more to do with the, depending on what side you were on, winning of World War II than any other single person, right? They could decode where German U-boats would be at a particular time of day because of his work. And a lot of other people, not just him. But the reason I'm putting him up here is because he had one of the first ever papers on AI called Computing, Machinery, and Intelligence. And he said definitions of machine and think are very difficult. It's almost impossible in my opinion. I agree with that. So he said the question of can machines think, I believe to be too meaningless to deserve discussion. Okay, I don't go quite that far. I think it's worthy of discussion. But what he did was he said, I'm going to pose this question as a game instead of a definition. So this was called the imitation game. And what you have here is you have some sort of divider, right? Whether this is a wall or it's across the country, basically C cannot see A or B, right? And they interact with A and B somehow. There's a human interrogator, so this person is human. There is a computer and a human, and they don't know which is which. Can the interrogator determine which is the human and which is the computer? That's the game, right? Who knows the more popular term for the imitation game? Back there? Turing test, right? So this is the Turing test, which essentially says, in a particular domain, can you tell the difference between a human and a computer? In some domains, it's very difficult. In other domains, it's very easy. So this is the standard interpretation of the imitation game. Can computers exhibit behavior which is indistinguishable from humans in some domain? Versions of this have been asked for centuries. Descartes was talking about automata back in the 1600s, right? And probably other philosophers from the Eastern world that I don't know about have been asking this question as well. Diderot talked about parrots. A parrot can literally speak English. Does that mean that that speaking of English is intelligent? Or are they just somehow mocking the sounds, right? Ayer talked about the consciousness of machines. Do machines that exhibit human behaviors have a consciousness? Are they self-aware, etc.? Like, tests have been done to show that certain animals are or are not self-aware. Could machines be self-aware in the same type of way? Here's another test. Not a test, but like a thought experiment. This is called the Chinese room thought experiment. The fact that it says Chinese doesn't mean anything. You could literally just put in any language here, right? But I like to have a little bit of fun. So the Chinese room experiment, brought up by Searle in 1980, goes like this. There's a box, a black box, right? The people on the outside cannot see what's happening inside this box. Inside the box, so what happens is someone out here passes in some characters or sentences or whatever to be translated by whatever happens to be inside this box. And I'm standing over here on the other side speaking a different language, and the text has been translated, right? But the person inside this box, unbeknownst to us, literally has a book, a giant book. This is a really big book that contains every possible input statement and every possible output statement, right? And what they do is they look at the symbol or the sentence or whatever, they look it up, and then they write down what they see on the other side of the book, and they pass it out. So, to the outside, it looks to be intelligent, right? This thing is capable of translating language. What a miracle. But on the inside, we know that what they're doing really doesn't require, it requires patience more than anything, because they're literally just looking it up. So I guess beyond the question of the vision recognition that has to happen, right? Where let's pretend it's in Braille or something, I don't know. But beyond the ability to optically recognize characters, this person does not understand the process of translation. They don't speak either language. And here's the thing. By looking up and performing translation, the person appears to know the language and appears intelligent, but John Searle argues the person in the box is what computers do. They just look up stuff, right? Whatever you run on a computer eventually gets translated to the machine code of that machine and gets run. Does the computer understand what it is doing? Is the computer intelligent? So if there's no understanding of the semantics, then even if the Turing test is passed, does it really mean anything? And so some people agree with Searle, some people don't, but there's this idea, this sort of romantic notion, romantic meaning not like love, but in a way that makes us feel good about being human, that no matter how smart a computer is, there's that human element that it's missing. It doesn't understand. What does understanding matter? As long as it gets the job done, right? So there's lots of interesting questions here. And so what is AI? What is intelligence? Can computers? All that, I'm not going to even pretend to answer that question. I'm just bringing up interesting thought experiments for you to draw your own conclusions. And at the end, whether or not you write AI programmer on your resume is up to you. So I like to explain, okay, rather than try and explain the term, let's show things that I would consider AI and what AI can do, and maybe that's a better way to understand what AI is. Planning and scheduling. This is my particular bread and butter. I love this. Algorithms for pathfinding, for example. If you've ever used TomTom or Google Maps or Apple Maps, well, if you made it here, you're not using Apple Maps. But really, one person? Okay. So Google Maps, it's all search algorithms under the hood with machine learning for heuristics and stuff. So we will learn this algorithm. And if I could give you the data set, I would. I tried. Couldn't get it ready in time. But we will be doing pathfinding and planning in this course. Autonomous control is a thing, right? So, there are self-driving cars out there that can sort of make it to their destination and sometimes not, depending on the weather and the traffic conditions, etc. So that's a thing that's happened in the last few years. Image and pattern recognition. When you send a letter somewhere, since the 80s, they have had machines scanning envelopes. And a really interesting anecdote is that back in the day, there used to be, so these sorting facilities for mail in the United States, there used to be 2 facilities, each employing thousands of people, 2 of them per state in the US. Because when you sent a letter, someone had to read it and put it in the right box, right? Then computers came along, got a little better at reading, got a little better, to the point now where I think there's 1 facility left in the entire country that actually employ people to look at letters. It has to be pretty bad for modern image recognition not to get it. There's also facial recognition, which I am a huge anti-facial recognition person. I don't think it should exist. I think it is only used to track people for nefarious purposes. I won't get into that right now. Sometimes you trade the convenience of unlocking your phone really fast for giving these companies a literal scan of your face to do whatever they wanted. Anyway, another topic. Healthcare is a big topic for AI these days. There's robotic surgeries. Over here you see people in our department are actually doing things with MRI scans, detecting tumors. One of the things that has to happen in hospitals is human beings circle a tumor, and then 6 months later they go circle it again, and they try and calculate how much bigger it is, because if it got bigger, that will tell the doctor what sort of dose of radiation you might need for cancer, but now computers are becoming actually better than humans at these sorts of problems as well. All sorts of AI problems in robotics. Over here we have like swarm robotics, where swarm robotics is a topic where if you take a bunch of things doing something stupid, it can result in a group of things doing something smart. Over here you see Boston Dynamics, for some reason, training the Terminator to hate human beings. But they've made great leaps with that. There is musical composition. This is just a funny GIF. This is I think it's what's the name of the band? Something Compressor Head, I think. It's just a robotic band. They don't actually compose the music, but there's AI. Who's seen like AI composed music? It's all the rage these days on YouTube. Hearing like SpongeBob doing gangster rap and stuff. It's surprisingly good, but also surprisingly scary. Lots of different art. This slide was made like 10 years ago. This is child's play in comparison to what's out there now. I love these things, like an oil painting of a ferret in a wedding dress getting married to a black and white cat in a tuxedo standing near a lake. Okay, there you go. That's just done. That's solved, I guess. You don't need artists for anything anymore. We have ferrets, so I'm big on the ferret art. Here we go. Solve my Comp 6980 assignment for me, please. I'm sorry, Dave. I can't do that, right? Yeah, so that's funny. I actually had to prompt it above to tell it to say that, because it'll try. Concept art for game development, it's so good at that. Maze generation, procedural content generation is something I'm interested in and have done. So, I have a video game, make the maps for me. Language processing and translation, I used this 10 years ago in Japan when I was there. I don't read Japanese, and I pointed it at a sign, and it did that in real time. Like, Google Translate can do this right now. It's insane. It's really good. It can obviously take over the world. This is AI forever has just been vilified in its ability to walk around and be invulnerable and shoot people. And who knew that the way it would actually take over the world is to influence elections and ruin toddlers' brains, right? Isn't it crazy? But I won't get into that. Game playing. Traditionally, AI needs to be tested somehow, right? Is this smarter than the last AI? So play a game. Does the new version beat the old version? Because there's a winner and a loser. We'll get into more game playing stuff as the course goes on, but this is where I'm really interested in it. So how do we make new AI? That's actually an interesting question, right? How does something go from not existing to existing? And the grad students in the class should probably, especially for thesis-based, pay attention to something like this. So R&D in AI goes something like this. This is a lot of hand-waving, right, over the details. You identify a problem or an area that you want to work in. So for example, I started my PhD at the University of Alberta, and I went there to do robotics, because the supervisor there, I did my master's in computer vision, and this guy at the U of A wanted to do computer vision, so I was like, sure, why not? And then I took a course with Dr. Michael Burrow, who just retired this year, and at the end of the course, he said, by the way, if anyone wants to work on StarCraft AI, let me know. And I immediately stopped robotics and went to the video games, because just my whole life has been all about video games. So you somehow identify that problem. Be lucky enough for a situation to arise where you can identify what you actually want to do with your life. It's a difficult decision. But whether or not, okay, I really like this video game, or I really, my mom had cancer, I want to solve cancer, or I really like neural networks, I just want to improve neural networks. Somehow identify something to work on. You do a literature review of existing techniques. This is probably the most important part, because in science and in publishing, there is no second place. Because if I'm the second person to publish something, who's to say I didn't just read the other person's paper and then write it down again, right? So you can only publish something for the first time. It has to be new. So you have to see what has been done in order to do something. Then you sort of, insert miracle here, where you work on the problem and you come up with a new solution to it. whether you take an existing solution and you tweak it a little bit or come up with a new little thing that makes it a little bit better, or you somehow have a miracle breakthrough where you invent an entirely new thing. You test new techniques against the state of the art under specific controlled circumstances. So you have to actually do some experiments and show. Like, it's no good to say, my model achieves 85% precision or accuracy. Okay, cool. Is that a good number? What was the previous thing? Was that 90? Was it 20? All of a sudden, your 85 means something different, right? So you have to compare. You apply the technique to the problem, and then, you know, whether or not your company is successful or you get your thesis or whatever comes next. But it's just like the step-by-step way that you gradually increment things. How do we test new AI? Well, one way that I'm very interested in is to play games, because games measure intelligence, right? Yes, sports measure intelligence too. If you play soccer or baseball or football or whatever, there is definitely strategy that goes in there. But games, especially board games, which were traditionally how you tested AI algorithms, they're purely strategic, meaning that, you know, you can assume that a user is able to move a chess piece on a chessboard. That agility or stamina or strength or whatever is sort of out of the picture. When it comes to something like soccer, well, you just give the robot rocket boots, and its strategy doesn't matter anymore, right? Because you can move at 200 miles an hour. So they're slightly different. And in my opinion, everything, without exaggeration, is a game. Okay? Why? How do I, like, okay, why say that? Lots of things are serious, but game doesn't mean it's not serious. What is a game? A game, and we'll talk about this a lot more in the next lecture, is an agent. Maybe I'm playing a game right now where my personal goal is to teach you, hopefully you learn something. Your goal may to be get, you know, an A in the course. You're playing a game as well. An agent is in an environment. The agent can take actions. The actions affect that environment somehow. And that agent has a goal. Whether it's defeat the opponent, move to the right, solve the puzzle, get the most points, it's just maximizing a function, right? And so when people, you know, you may have heard throughout your life someone say, oh, that's a very selfish person, or that's a very giving person, or that's a very selfless person, or altruistic, or philanthropic, or whatever. Let me tell you right now, everybody is selfish. Everybody. But each of us has a different function we are trying to maximize. Maybe my function is to teach you as well as possible. Maybe your function is to get the most physically attractive partner and the Lambo or whatever for any of the crypto bros out there. Some of you want to maximize income. That's a fun, like it's all fun. Who am I to judge your maximization function, right? Maybe it's just to find the person you can cuddle with on Sunday morning or whatever, have a couple of kids. Everybody is selfish within their own function. It's just that their function may benefit themselves or others more or less, okay? So we'll talk about a little bit about game theory, decision making. Like these stuff is just not taught in schools. So everything's a game, whether or not you believe you're playing it. And so decision making within those games to accomplish goals is important. AI in games, why is that such a good combo? Well, it's because at least modern games can simulate the real world. And typically, if you have a game that's like difficult or complex enough, then success in that game means that, okay, I can go apply this somewhere else. Like, for example, there was a guy who applied deep neural networks to teach his character in Grand Theft Auto 5 to drive a car. So in Grand Theft Auto, which is pretty realistic, right, if you ever played it, it's not photorealistic, but he took the same model that learned to drive around, you know, San Andreas or Vice City or whatever version of the game he was playing, put it into a real car, and it drove surprisingly well, right? I wouldn't necessarily want that model in my Uber, but like the goal showed that, okay, you can use games to simulate these real environments. There are no ethics required for games. So ethics, I don't mean that you don't have to think about games or like what they mean, But ethics requirements for research are when, like, okay, I'm developing a new drug, I'm going to need to test it on rats or something like that. So you have to write this detailed proposal to the funding agency or the university and say, here's how many rats per second I'm going to need to kill or whatever. Or I'm going to need to ask some people, like, there may be, for example, one person I knew was doing research on autism, right? And so they developed this game that autistic people were going to play, and then they were going to ask them some questions. And anytime you interact with humans, that may be a traumatic experience for somebody. If you ask someone a question and you didn't know, like, you know, that some family member may have, you know, had some experience that was traumatic for them, you have to go through all these ethics requirements in your research if you're dealing with living, breathing things. AI doesn't have, or video games don't have that. So it's a very good way to test things. It's super cheap. You go out and build a $10 million robot versus just driving something around in GTA. They're easy to visualize, and they are intuitive. They are fun to program and play, and they help motivate people to learn. And that's my goal here, is that, okay, look, this is kind of like a game. That's pretty neat. I wouldn't mind coding up something in that. Versus, you know, okay, go write me this class and just pass it in. You're working entirely in the console. Just try and make it a little bit more exciting for people. So when I first made this slide for a talk, I think it was in 2012. So it was a long time ago during my PhD. And at that time, human versus machine, chess. Can anyone name, just put your hand up if you know the name or the year of the system that beat the world champion at chess? Back there? Deep Blue. What's that? I think it was 1997. So in 1997, Deep Blue from IBM beat Garry Kasparov using techniques and algorithms that you will know from this course. So we'll talk about that a bit more. Checkers was solved by Jonathan Schaefer at the University of Alberta. What do I mean by solved? It means that he has like a 20 terabyte hard drive somewhere with every possible checkers position on it and what move to play at that position. So the game is solved. If we talk about solving a problem from a game theoretic or algorithmic point of view, our definition of solving a problem means that this is provably correct. If you go to a company and they say solve this problem, it will mean you have something that works, sort of, right? A solution in computer science game theory is something that's different from industry. So in this course, when we talk about solving problems, we mean coming up with a provably correct answer. When I wrote this slide, there were many people working on Go, and then in 2016, AlphaGo beat the world champion, Lee Sedol, at Go. And the only thing left on this slide are the most complex video games that AI still has not beaten the world champions. StarCraft, those AlphaStar that Google DeepMind wrote that beat some professional players, never actually had the world champion that was beaten. Things like Dota or League of Legends, it just costs so much currently to train these big models on these games. I think companies have just kind of given up on it. And the last thing I'll say, I'm going to skip a few slides. There's lots of benefits of game AI, etc. I run this MUN AI in Games lab. I'm not going to go into that too much because the slides are there if you want to look at those things. But the MUN CS courses that have something to do with AI, or at least when I wrote this, so there's this course, there's Nature-Inspired Computing, which is also an excellent course. There is Intro to Machine Learning, which goes over all the cool machine learning stuff that I do not go over in this course.